This is Edexcel's Cumulative 3, paper 3H. Question 1. Write 168 as a product of its prime factors. So 168 can be split into 2 times 84. 84 can be split into 2 times 42. 42 can be split into 2 times 21. And 21 can be split into 3 times 7. So 168 would be 2 cubed times 3 times 7. It says find the highest common factor of 168 and 180. So we've already got the prime factor decomposition of 168. So I'm going to do 180 separately. So 180 would be 2 times 90, which is 2 times 45, which is 9 times 5, which is 9 is 3 times 3. So we've got 2 times 2 times 3 times 3 times 5. So to put this into a Venn diagram, the highest common factor are the numbers in the middle. So if we put 168 in here and 180 on this side, so they've each got a 2 squared in it, so they can put 2 2's in the middle. They've each got a 3 in it, so 168 would be a 2 missing and a 7 missing, and 180 has a 3 missing and a 5 missing. Now those aren't so important because we only need the ones in the middle, so the highest common factor would be 2 times 2 times 3, which is 12. Question 2. It says Eric and Geraldine both drove from town A to town B. Both Eric and Geraldine left town A at 2 p.m. Eric drove on route 1 and got there at 2:48, and Geraldine drove on route 2 and got there at 3:25. Who drove at a greater average speed? So first of all, he took 48 minutes and she took an hour and 25, which is 85 minutes. We're best off keeping this in minutes because going to hours, it ends up being decimals that are quite difficult to work out. So to work out Eric's average speed, he is covered, so on route 1, it's 36.4 miles in 48 minutes, but we want it in miles per hour, not miles per minute. So we need to times that by 60, which will give us 45.5 miles per hour. And Geraldine, she covered 65.2 miles in 85 minutes. So again, that would be in miles per minute. So we need to times that by 60 to get in miles per hour, which would be 46.0 miles per hour. So Geraldine had the greatest average speed. Question 3. Here is an accurate scale drawing of a school playground. 1 centimetre represents 2 metres. Nazim is going to put a seat in the playground. It has to be more than 9 metres from C. So first of all, 9 metres using this scale would be 4.5 centimetres, just divided by 2. It has to be closer to BC than AB, so this is going to be an angle bisector, because I want to find closer to BC than to AB, which is this. So I want to be down here somewhere, so it's going to be an angle bisector, and more than 4 metres from AB, so that is 2 centimetres on this drawing. So I'll start off with the first one. To be 4.5 centimetres from C, you put your compass at C, go out to 4.5 centimetres, which is difficult to show you on here, but it's about there, and you draw your line up using your compass. It says to be closer to BC than AB, so we need to do an angle bisector. So you put your compass here, you do your curve here, and then put your compass here, you draw a curve there, put your compass here, you draw a curve there, and that will give you your angle bisector, which goes through like that. It also says it has to be more than 4 metres from AB. So 4 metres from AB would be 2 centimetres on our drawing, which is just about here. So we go over. I think I'm a little bit out with this, but you need to do it accurately with a ruler and compass. So the area that it will be allowed to be in is this area here, for your 4 marks. Question 4, it says there are only red counters, blue counters and green counters in a bag. The number of red counters to blue to green is in the ratio of 1 to 3 to 7. Complete the probabilities. So first of all, probability must be in a fraction, decimal or percentage. So these are 11 counters altogether. So there is 1 out of 11, which is red. There are 3 out of 11 blues, and there are 7 out of 11 greens. So fractions, decimals or percentages only. It says Jamie takes at random a counter from the bag and records the colour of the counter. He then puts it back in the bag. Jamie does this a number of times and he records a total of 68 blue counters. Work out an estimate for the total number of times it takes to count it from the bag. So 3/11ths of the time must be this 68 counters. So to work out how many there must be in the bag altogether, we need to work out all 11/11ths. So if we do 68 divided by 3, that would give us what 1/11th is, so 22.6 recurring. And to get 11/11ths, we need to do 22.6 recurring times 11, which will give us 249.3 recurring. So we'll call that 250 counts, because it's more than 249. Question 5. Mariam is trying to expand and simplify n minus 2 squared. Here is a working. Mariam has got the answer wrong. Find Mariam's mistake. So n minus 2 squared does mean n minus 2 times n minus 2, so that's correct. When you say expand it, you've done n times n is n squared, minus 2n's, but minus 2 times minus 2 should be plus 4 here. So I find it useful to circle the mistake that she's made and then describe it on the lines given. So minus 2 times minus 2 equals plus 4, not minus 4. It should be, and it's always good to correct, it should be n squared minus 4n plus 4, just to clarify exactly what you were talking about. It says Josh is trying to factorise x squared minus 6x plus 8. His reasoning is 4 times 2 is 8 and 4 plus 2 is 6, so it gives that expansion. Explain what he's done wrong. So here we're going to explain it with his reasoning. So his reasoning has gone wrong just here. It's correct to look for two numbers that multiply to give 8, but they should add together to give minus 6. So I've highlighted the bit where he's gone wrong, and I'm going to explain. He should be looking for numbers that add to give minus 6, not 6. And again, it's always good to correct it. So e.g., it should have been x minus 2 and x minus 4 would give you x squared minus 6x plus 8. Shauna has to draw the line with the equation y equals 3x plus 2, and here's a line. Explain why Shauna's line cannot be correct. Well, we know that y equals mx plus c, where m is the gradient and c is the y-intercept. We can't do anything with the gradient because we don't have any numbers on here, but we do know that the y-intercept should be at plus 2, and it's actually at negatives, isn't it? So we need to write the y-intercept should be at plus 2, not negative. Question 6. The diagram shows a quadrilateral JKLM. Work out the size of angle KLM. So it's this angle here that we're after. So I'm going to call that X. First of all, we don't know any, we've only got one side in here, we need two sides. So we can work out this side here because we have a triangle here which we can use Pythagoras in. So I'm going to call this y. So y squared would be equal to 4.5 squared plus 7 squared. So y is equal to the square root of 4.5 squared plus 7 squared, which is 8.32 carrying on. Again, leave this in your calculator to be used next. So now we know what this is. We can say that sin x is equal to the opposite, which is this 8.32, which should be still in your calculator, so you don't need to write it out again, divided by the hypotenuse, which is 15. So we're using sin because we've got the opposite in the hypotenuse. So to work out x, you would do sin to the minus 1 of 8.32 over 15, and that will give you 33.69 degrees. And again, to three significant figures, that would be 33.7 degrees. Really important you leave this number in your calculator so you get an accurate answer. Question 7. Liquid A has a density of 1.42 grams per centimetre cubed. 7 centimetres cubed of liquid A is mixed with 125 centimetres cubed of liquid B to make liquid C. And liquid C has a density of 1.05. Find the density of liquid B. So liquid A, we've got 7 centimetres cubed, and each weighs 1.42 grams for every centimetre cubed. So that gives us a mass of 9.94 grams for liquid A. On liquid C, we've got 7 plus 125 centimetres cubed, so that's 132 centimetres cubed, and every centimetre cubed weighs 1.05 grams. So that would be 138.6 grams for the mass of C. So B then must have a mass of 138.6 minus, which is C, minus the mass of A, 9.94, which gives us, and then we need to divide that by 125, which is the volume of B. So if you put that to your calculator, you will get 1.029 grams per centimetre cubed. And for two decimal places, that would be 1.03 grams per centimetre cubed. Question 8. Kira used her calculator to work out the value of a number x. She wrote down the first 2 digits of the answer on her calculator, and she wrote down 7.3. Write down the error interval. So if she's written down 7.3, the calculator must have said 7.3, then with something after it. So the smallest number it could have been is just 7.3, and the biggest number it could have been is just less than 7.4. So it could have been 7.3, 9 recurring. So putting this in using inequality signs, it could have been greater than or equal to 7.3, but it had to be just less than 7.4. Just be careful, a lot of people would have put 7.25 to 7.35. That's when a number is being rounded. This is when the number is being truncated. She's just cut off all the numbers. She's not rounded it, she's just cut all the numbers off. Question 9. Francesco carried out a survey about the ages of people in his office. The table shows information about his results. On the grid opposite, draw a cumulative frequency table. So we've already got the cumulative frequency, so we don't need to do anything with it. We just need to plot these points on the graph. So the thing to remember with cumulative frequency graphs is that you plot the end point, because the first group says there were 10 people aged 30 years or younger. The second group is 40 years or younger, 50 years or younger, etc. So the first one we're going to plot is at 30 years or younger, there were 10 of them. 40 years or younger, there were 26 of them, so as accurate as you possibly can. 50 years or younger, there were 58 of them, which is just there. 60 years or younger, there were 66 of them. And then 70 years or younger was all of them, 70 of them. Now the minimum age was 20 because it starts at 20. So we're going to start at 20 and we're going to draw our curve as accurate as you can up there like that. It says use your graph to find an estimate for the median. So if there are 70 people, the middle person, which is the median, must be at 35. So we're going to go to 35, we're going to go across and we're going to read off, and the answer is 43 years old. It says Francesco says that more than 60% of people in the office were aged between 35 and 55. Was he right? Well, 60% of 70 is 42 for starters. So we need to say that there were more than 42 people aged between 35 and 55. So if we look at our graph, age 35, we'll go up here and read off, which means there were 16 people or less. At 55, which is just here, we go up again, put your lines in. We've got 63 people, so 63 take away 16 would be 47 people between that. So there are 47 people. So it says more than 60% of the people were aged between 35 and 55 years old, and there were 47 people. So she's absolutely right. So yes, 47 people were between 35 and 55, where 60% was only 42. Question 10. In a sale, the price of the TV is reduced by 25%. A week later, the sale price of the TV is reduced by 15%. The price of the TV is now £293.25. Work out the price of the TV before the sale. Well, before the sale, we don't know what price it was, so we'll call it X. To knock off 25%, you'd multiply that by 0.75. And then whatever you got, to knock off another 15%, you multiply that by 0.85. And that will give you the £293.25. So to work out what x is, we just do 293.25 and divide that by 0.75 times 0.85, and that will give us an answer of £460 for the original price of the telly. It says expand and simplify x plus 2, x plus 8 and x minus 4. So the way I'd do this is I'd do the first two brackets first and leave the third one alone, and then do the third one after. So x times x is x squared, plus 8x's, plus 2x's, plus 16, and we multiply that still by x minus 4. So simplifying that out before we do, we'd have x squared plus 10x's plus 16, and we want to times that by x minus 4, and to multiply that by x minus 4, we're going to multiply all through by x first. So multiply each bit by x, we'll have x squared times x is x cubed, plus 10x squareds, plus 16x's. We then multiply through by minus 4, so that gives us minus 4x squareds, minus 40x's, minus 64. Now if we simplify that all together, you've got x cubed plus 6x squareds minus 24x's minus 64. Question 12. The diagram shows a metal rod AB resting inside a cylindrical tin. The tin is on a horizontal table. AC is the diameter of the base of the tin. B is on the top edge of the tin and BC is vertical. The radius of the base is 5 centimeters and the volume is at 1178. Find the angle between the base of the tin and the rod. So we're after this angle here, where this is a right angled triangle. So first of all, if the base has a radius of 5, then all the way across must be 10 centimeters. We just need this distance here to be able to work out this angle here. So we need to work out the height of the tin. So to work out, we are given the volume, and to work out the volume you do pi r squared, so the area of the bottom, so pi times 5 squared times by the height, and that will give us 1178. So to find the height, we just do 1178 divided by pi times 5 squared. So the height is 14.998. Leave that in your calculator, it's a bit more than that. So to work out the angle, we've got the opposite and we've got the adjacent. So we're going to use tan. So we're going to do tan x, if we call the angle that we're after x, is equal to the opposite, which is 14.998, making sure you use the full calculator display, divided by 10. So x is tan to the minus 1 of 14.998 over 10, which will give you 56.3, but it's asking it to the nearest degree, so 56 degrees. Question 13. For any three consecutive whole numbers, prove algebraically that the largest number and the smallest number are factors of the number that is one less than the square of the middle number. So, a bit of a mouthful, but we just need to write down three consecutive numbers. So if the first number is n, the next number would be n plus 1, and the next number after that would be n plus 2. It says we need to work out the square of the middle number, but then take one off it. So we need to do n plus 1 squared and take one off it. So n plus 1 squared will give us n squared plus 2n plus 1, and then we need to take one off it. So that will give us n squared plus 2n. Now, if I factorise that, they've both got an n in, so I can factorise that to be n brackets n plus 2. So you can see, this is the smallest number, and this is the largest number. So we just need to write, therefore, the smallest and largest numbers are both factors. Question 14. It says, prove algebraically that the recurring decimal 0.457 with dots above can be written as 151 over 330. The first thing you should always do is call the decimal that you've got, x, and write out what it is. So you tell the examiner you know what it is, because that's where the first mark is. So it's 0.575757. You should always write at least 6. So I've done 575757. Multiplying that by 10, because I want to get rid of that 4, 10x would be 4.575757. Now, at this moment, we've not got the tens column here being equal, so I need to multiply that by 100, which will give me 1,000 x's, and that will give me 457.575757. Now I've got two numbers that have the same decimal places in. So when I take these two away from each other, I get 990 x's, and 457 take away 4 is 453, and the decimal places will all cancel out. That was the whole point. So x would be 453 divided by 990, and those can both be divided by 3 to give 151 over 330. You can use your calculator to do that anyway. Question 15. On the grid, show by shading the region defined by these inequalities. So, x is less than 4. So the x-axis is at 4, less than is a dotted line. So we need to put a dotted line down here. And I want it to be less than, so I'm going to be this side of it. So I'm going to put a little arrow on reminding me that it's this side of it. This one, I'm going to rearrange into the form y equals mx plus c. So it'll be minus 2x plus 6. So this is going to have a y-intercept of 6, so it's going to start here, and a gradient of minus 2, so it's going to go across 1, down 2, across 1, down 2, across 1, down 2, like that. And again, it's a dotted line, because it's just greater than. And to be greater than it, it's going to be above the line, so I want this side of it. Y is greater than a third x, so it's got no y-intercept, so it's going to cross at 0. So it's going to cross here, and a gradient of a third means it will go across 3, up 1, across 3, up 1, and so on. And again, this is going to be a dotted line, so it's going to be a dotted line through those points. And I want y to be greater than, so it's going to be above it. So you can see the region that I'm after is this region here, all the way down to there. Question 16. It says there is a large number of cubes in a bag. Jason wants to work out an estimate for the number of cubes in a bag. He takes at random 10 cubes and puts a mark on each of them. So he marks up 10 cubes, and that will be the same ratio to the entire population, which we don't know yet, which is x, as his sample. And when he does a sample, he pulls out 20 cubes, so the entire population of his sample is 20, and he pulls out 3 marked ones. So these are the marked ones. This is the entire population that we're looking at. So to get from 3 to 10, we are going to multiply by 3.3 recurring. So to get from to our full population, we need to multiply by 3.3 recurring. So 20 times 3.3 means that x must be 66.6 recurring, or 67 counters in the bag. Question 17. At the start of year n, the quantity of radioactive material is Pn. At the start of the following year, the quantity is given by Pn plus 1 is equal to 0.87 Pn. At the start of 2016, there were 30 grams of metal. What is the quantity at the end of 2019? So, first of all, if we use this equation, in 2016 there was 30 grams. So to work out 2017, we will do 2016 times 0.87. So 0.87 times 30, which gives us 26.1. To work out 2018, you just do 2017 times 30. So that, sorry, times 0.87, sorry. So 0.87 times 26.1, which gives us 22.707. And to get 2019, you just put 2018s in. So 0.87 times 22.707, and that will give us 19.75509. And it asks to the nearest gram, so that would be 20 grams to the nearest gram. Question 18. Here is a sketch of the curve y equals sin brackets x plus a plus b. Given that x is between, a is between 0 and 360, find the value of a and b. So first of all, this number here will move it left and right, and this number here will move it up and down. So we need to figure out how far left and right and how far up and down it's gone. So the sin curve usually starts at 0 and goes through 90, down to 180, down to 270, and back up to 360, between 1 and minus 1. So we can see that first of all, this point here has been moved over to here, so it's been moved left 90. So to move left 90, you need to add 90 on. So A must be plus 90. It's also moved down 1. So to move down 1, the number on the end must be a minus 1. So it'll be 90 and minus 1. Question 19. The diagram shows triangle ABC. AB is 3A, AC is 2B, and B to E is 3 lots of A to C. So first of all, I'm going to write that down straight away. This here must be 6 B's. It says D is a point on BC, so it's BD and DC is in the ratio 3 to 1. Prove that ADE is a straight line. So to do this, I need to find the vector for AD, I need to find the vector for DE, and then I need to prove that they are parallel to each other and that they share the point D. So that's the method that we're going to use. So first of all, we're going to have to go up and down this vector here. So we need to work out this vector. So I'm going to work out what CB is. So to go from C to B, I need to go backwards along here, which will be minus 2Bs, and then up here, which will be plus 3As. So we've got that CB is minus 2Bs plus 3As. So I can now work out AD. So AD, I'm going to start at A, I'm going to go along here, which is 2Bs, and I'm going to go up here, which is going to be 1/4, so that this is in quarters. So this will be 3/4, and this will be 1/4. So this is going to be 1/4 of CB, because I'm going up it. So we're going to add on 1/4 of minus 2Bs plus 3As, which we just worked out. Simplifying that out, we would have 2Bs, and then 1/4 of 2, or minus 2, is minus 1/2. So it'll be minus 1/2 B plus 3/4, because 3 times 1/4 is 3/4 of A. And simplifying that out fully, you'd have 1.5 Bs plus 3/4 of an A. I now need to work out DE. So to get from D to E, I'm going to go up here, which is 3/4 of CB, and add on 6B. So it's going to be 3/4 of CB, which was minus 2Bs plus 3As, and then I'm going to add on to that 6Bs. And again, simplifying that out fully, 3/4 of 2 would be 6/4, but it'd be minus 6/4. So it'd be minus 6/4 B, and 3/4 of 3As would be 9/4. So we're going to add on 9/4 of A, and then add on 6Bs. So simplifying that out, 6/4 is the same as 1.5. So 1.5 taken off 6Bs would end up with 4.5 Bs, and we've got 9/4 of A. So 9/4 of A, in fact I'm going to leave that as 9/4 because it'll make the factorising a little bit easier. So 9/4 of A, I could have written that as 2.25, but I'm going to leave that as 9/4. So to show that they are parallel, I need to factorise this, okay, to show that it's the same as this. So I can see that I need to multiply 1.5 by 3 to get to there, and I need to multiply 3/4 by 3 to get to 9/4. So I can factorise this to be 3 lots of 1.5B plus 3/4 of A. So that shows us that DE is equal to 3 lots of AD. So they are parallel. If they are parallel, it means they have the same gradient. Okay. They also share point D. So if they are parallel and share point D, therefore ADE must be a straight line. Question 20. There are 9 counters in a bag. There is an even number on 3 of the counters, and there is an odd number on 6 of the counters. 3 counters are going to be taken at random from the bag, and the numbers on the counters will be added together to give us the total. Find the probability that the total is an odd number. Well, the first thing we need to remember is that an odd plus an odd equals an even, and an odd plus an even equals an odd. We also need to know that an even plus an even is an even. So thinking about that, the only way of getting an odd total off these 3 numbers is by having all 3 of them odd, or any combination of 2 of them being even with 1 of them being odd. So we could have the first one being odd and the other 2 even. We can have the first one even, the middle one odd, and the last one even. Or we can have the last one being odd, so it'd be even, even, odd. So let's think about some probabilities. Probability of the first one being odd would be 6 over 9, because there are 6 odds and 9 altogether. The second one being odd would be only 5 left that are odd and 8 in the bag, and then the before odd and 7 in the bag. And that will give us 120 out of 504. Similarly, probability of the first one being odd is still 6 out of 9, but then the next one being even would be 3 out of 8 because there's only 8 in the bag, and then 2 out of 7 because there's now only 2 evens and 7 in the bag. And that would give us 36 out of 504. Even, odd, even, that would give us 3 9ths times 2 8ths times 3 7ths, which again is 36 out of 504. And then even, odd would be 3 9ths times 2 8ths times 3 7ths, which is 36 over 504. Now you could have done this with a tree diagram, but a 3-stage tree diagram gets really, really complicated. So you're best off just trying to think of all the different combinations. So we're not bothered which of these happens, because each of these gives an odd outcome. So we're going to add all these together. So the probability of the total being an odd is going to be all of these added together, which is 228 over 504. Question 21. F of x equals x cubed and g of x equals 4x minus 1. Find f of g of 2. So what this means is, it means to put 2 into g of x and then put the answer to that into the function f. So if we put 2 into g, we've got 4 times 2 is 8, take away 1 is 7. And if we put 7 into the first one, 7 cubed is 343. It says hx is equal to f of g of x. Find an expression for h minus 1 of x. So if I call, just for simplicity, h of x, I'm going to call that y, because I'm going to do some rearranging in a minute. That is equal to f of g of x. So f of g of x is 4x minus 1, and f of that would be to cube it, because you just put that into the original, so as x. So it would be 4x minus 1 cubed. Now to find the inverse, we want to rearrange all of that, so 4x minus 1, to make it x equals. So first of all, I'm going to get rid of this cubing by cube rooting. So we'll cube root both sides. We have cube root of y is equal to 4x minus 1. We're then going to add 1 to both sides. So we've got cube root of y plus 1 is equal to 4x. And then divide by 4, I've got the cube root of y plus 1 divided by 4 is equal to x. So to find h minus 1 of x, originally we called it y, just to save confusion, but we actually want it to be an x. So we're going to call that cube root of x plus 1 over 4. The reason I called it y rather than x is just so I don't get mixed up between this x and the x that would have been there. So I'll just call it a different letter and put it back to x in the end. Question 22. The diagram shows a circle with the equation x squared plus y squared equals 261. The tangent to the circle is drawn at point A with coordinates p minus 15, where p is greater than 0. Find the equation for the tangent of A. So first of all, we need to work out what p is. So to work out what p is, p would be this distance across here. So I'm going to call that p. We know that this is down at minus 15. And we do know this length here, because the radius of this circle is going to be the square root of 261. Now the square root of 261 is 16 point something, but I'm just going to leave that as the square root of 261. So to work out what p is, which will give us this coordinate, all we do is, to work out p, we would do the square root of the hypotenuse squared, take away the 15 squared, and square root it. So to work out p, we do the square root of 261 minus 225, and that will give us a square root of 36, which is just 6. So this value here must be 6. So A is at 6 minus 15. So now we know that coordinate, we can find the gradient of this line here, and the gradient of our tangent will be the negative reciprocal of that, because it's going to be perpendicular to it. So the gradient of OA is going to be negative for starters, because it's pointing in the negative direction, and it's the difference in y, which is 15, divided by the difference in x, which is 6. So 15 divided by 6, we can simplify that down with negative 5 over 2. I'm going to leave it as a fraction, because to convert that to find the gradient of the tangent, So the gradient of a tangent will just be the negative reciprocal of that. So I'm going to change it to a plus because it was negative before, and the reciprocal just means to flip it upside down, so it'll be plus 2/5. So the equation of our line will be y equals 2/5 x, and then plus or minus some number on the end. Okay. Now we do have some values we could put in this. When x is 6, y is minus 15. So I could put minus 15 is equal to 2/5 of 6 plus or minus c. Now I'm just going to go up here for some extra space. So 2/5 of 6 is just going to be 12/5. 2 times 6 is 12. Plus or minus c. Now to get c on its own, I'm going to take that 12/5, so 2 and 2/5 off the other side. So 2 and 2/5 off that will give us minus 17 and 2/5 for c. So c is minus 17 and 2/5. So the equation of our line is going to be y equals 2/5 x, the gradient, minus 17 and 2/5.